talking about my journey in geotechnical engineering. I think, I want to say something about it. The geotechnical engineering is a part of civil engineering. It is connected with all ground engineering. Like you must have seen a lot of landslides, contamination, and a lot of infrastructure problems in the country and all of that. So this geotechnical engineering talks about handling those problems in a very sustainable way. I think today we had Chief Guest talking about sustainable engineering and all of that. So I was working in different areas like how do you treat ground, and it is an important area, and millions of money, a lot of money is spent on that, but then you have a lot of infrastructure problems. We have certain materials there, geosynthetics. There's the landfill engineering, which is so important. In fact, a lot of dump sites in the country we have, and in fact, some of my colleagues are also working here. So the dump sites is something an issue, like in Delhi, we have serious problems. We have been working on that. The sustainability is something that's so important that people have been talking about. And risk and reliability, something that I've been working. Because when you're trying to talk about hazards in nature, that there is always uncertainty, so we try to estimate the risk. So we're trying to see how the risk can be reduced with proper ground engineering. That's what I was doing. So as I just said, we had number of papers and all of that. We had number of research projects. I just want to tell you that particularly on the dam safety, particularly when the bridge earthquake came, how safe is safe is something that we need to understand. And we're trying to understand, how like using the probabilistic methods, how these dams reconstruct safe or not is from a BSc project, then even on the infrastructure, buried objects, landslides, and we had certain projects on, for the Ministry of Road Transport on how we improve their retaining systems using soil technique and some of them, even the use of plastics waste in road construction. And the other thing that I was just mentioning was this characterization of principal solid-based characteristics is something very, very important. Like, there is a lot of waste material that is wrong. And in fact, I think my work was one of the first of its kind in the country. They were able to characterize the systems completely, and it's well cited. In fact, now we are trying to, Swachh Bharat mission is with us in trying to understand, now the scenario is completely different. How do you try to characterize the waste in the whole country and come up with some proper measures? And so we also worked on, for BRNS and other things. This is about road construction and landslides work, some of that. This is again, I think the methane gas emissions is something a big issue in, pollution. So we have worked on that. Even the other one that it's a big project on rehabilitation of dump sites in the country. How we can rehabilitate them for the people from Bangalore. You should know that there are 300 acres of dump sites in Bangalore. You go to any corner, any side, you have a dump site, like say Mandor is one side with 110 acres. And how do you handle that is something an issue. So we're trying to address some of those issues. And even we're trying to estimate methane gas emissions from paddy fields because once somebody wanted, when I'm measuring methane from landfill, somebody said, why don't you measure methane from paddy fields as well? Because it's a controversy was there. And there was some more work. A lot of work on ground improvement and expand soils was done. And how, forensic studies, things happen. A lot of infrastructure failures are there. How do you understand the failure? It's called forensic analysis. And how do we rehabilitate? So, for example, I can give you a number of cases where we are able to rehabilitate in a very, very cost-effective way. And I can show you some examples. These are some contributions on guidelines. In fact, when you are as a civil engineering professional, you need to really do a lot of technical contributions on the specifications. We're able to do many of them. I'll give you some examples. Like, say for example, this is for the Ministry of Defense. See, this underpass set in ISC. Some of you who visited, there was no. This was constructed in a very short, a very nice way without disturbing, cutting this trees. I think some of you must have passed. Because when the contractor was refusing to construct, there was delay. The professor joined together to construct. Then the Ministry of Defense came to know about it, and they came to me. At that time, I think Ministry of, actually they wanted an underpass for the Asanka, they wanted in 6 months. I said, they had an error. I said, how is it possible? Even awarding a contract to the government of India standard 6 months. I said, we'll give money to IISc, we do it. So this was work that we did in 6 months. I was a project in charge, where there were just they said, you do whatever you want, we'll give a lot of money to IISc. We just gave it, and we did some underpass where, I think some of there's a technical side, there's a, people decide. So that's a very interesting work. We use a soil layering and box pushing without disturbing the traffic. It's a 36 meters width of road. It is not disturbed at all, even for the day. This is another road that, it was about 800 meters length of the road. Before it was open for traffic, it sank. As we saw the little problems, and when the cost of rehabilitation, the demolition and reconstruction was about, it should have costed 16 crores. We were able to rehabilitate in about 4 crores. These are all lot of things that we were able to rehabilitate without, the way that we do work in rehabilitation government, like we see, the way that the traffic, anything you do, there's so much delay. Causing a lot of issues. There's a lot of other techniques that we develop for rural road construction. And this other thing, the contaminated sites that I have been working. In fact, Pune is one of the critically polluted sites in the country. Bangalore residents we know. And so we are just working on, this is one of the critically polluted sites. So in fact, we were able to come up with remediation for both water as well as soil. In fact, my principle was that if you remediate soil, you don't need to pay a lot of money for the remediation of water contamination. So this is something that we worked on. These are some examples. This is about our this Balangur site, which is very close again. You have a lot of contaminated sediments with cadmium and all of that. These are about soil remediation. How can you really remediate soil, make it suitable, and then all the material that you have, the sediments that can be used for bricks or whatever. So in fact, I was in touch with BD and other agencies that we can take up this work. So it was a successful work. So yeah, there is some more work on dump sites and a lot of this. In fact, again, this is the first project that we did on, we in Bangalore, the NGT is putting a lot of fines to Bangalore, BBMP will be knowing. And there's a big dump site of about 25 acres, somewhere this side, not towards airport side. You can see methane gas coming out, leachate is on there. We're able to really collect all the methane. In fact, unfortunately, BBMP is handling it but then they're not really well. But we're able to come up with a system where all that methane can be captured. There's another thing that we did on landslides. Okay, so then sustainability is another one that I've been working. The other thing that I just was that in IISc, these are all on sustainable engineering, because that's we are trying to talk about climate resilient and sustainable, because these are payments. Because in Bangalore, we know that every 2 hours of rainfall could cause a lot of drainage problems. So how do you go with climate resilient designs is something that we try to do, like considering the climate changes. And this other important project, actually, I'm the national coordinator for this project on solid-waste management practices in India for selected cities, probably Principal Scientific Advisor, Office of the PSA, where we are looking at life cycle analysis, like, so the way that dumping practices are there. So we're looking at all of this, life cycle analysis, and I think continuing education, actually, they must take note of it. Actually, I've been the chair for 10 years, and CC, where it's about, it's a more startup, about 20 crores of revenue in 10 years. And new MTech online courses were introduced on emerging areas. I think today it was a very interesting thing that we did. So MTech online was introduced. Other thing that actually I wanted to point out too, because we are high level, IITs are recognized for the continuous education program, whatever was mentioning. But IISc, what is there in there? It is not there, at least, which is a bit surprise to me. That I request that to see that IISc also is a partner in that, because we are doing so many courses for professionals in this part of the country, and that will be a big boost. So that's what I want to say. And a lot of service professional organizations, a lot of service, because understanding failures is something important, understanding risk is important. I was editor-in-chief for a journal, and I was also the international, there are many positions that I had. So a lot of even other services we did. So I just want to close at this point.
First, I will start my presentation acknowledging INA. So I convey my sincere gratitude to INA for nominating me as a fellow this year. Then my teachers, Professor P.P. Mujumdar from IISc Bangalore, with whom I did my master's project and as well as my PhD. Professor Sorvadri Simonovic, Professor K. Rekha for my postdoc supervisors. And also my parent department in Environmental Science and Engineering, and also I'm the chair professor in Center for Climate Studies since last around 13 years. All my students, they are most important to me. So whatever I'm going to present actually is their work. My collaborators, my colleagues in my departments, also my funding agencies. So I was fortunate enough to get multiple projects from different government agencies and huge amount of support from them. Also data sharing, like organizations, particularly I stay in Mumbai, so MCGM and also MMRDA, they are very kind enough to share a lot of data with me. Also permitted me to do a lot of surveys. Also, Odisha's Space Application Center, OSAC, actually because of them I could conduct a detailed survey and also flood modeling over Jagat Singapore district in Odisha. Yeah, so a big thanks to them. I just want to show you my area of expertise because actually I'm a hydrologist. I have some special interest on socio-hydrology where I try to include the vulnerability and exposure component with the hazard so that we can generate the risk, actually mainly focusing on climate risk. And so this is the research vision. So if you see that advancing hydroclimatic risk analysis, mainly focusing on hydroclimatic risk and also working on social aspect. I know there is always a gap between social scientist and technocrat. So trying my best in the last 13 years to bridge this gap. Also trying to develop an integrated modeling and advanced forecasting technologies. And I'm going to show you that how this could be like adopted different at local scale, regional scale and national scales also. Definitely, different kind of global data are available. So how to utilize them to solve many regional and local problems. And which is very aligned to today's topic, like few slides I have which I would like to show you. But more detail you can get from this website. So you can scan the QR code to get all the details. So just before I start the presentation, I mean the topic, or to show the work which we have been doing. Just the concept of risk, I mean the traditional concept of risk and how it emerged to the climate risk. So risk basically is nothing but a combination of probability and the severity of adverse effect given by Lawrence in 1976. And if you see that Haynes and others, so many people in sometime in 80s, early 80s, so they worked in this area and they mentioned that risk assessment and risk management are basically answering these triplet questions, where these triplet questions, if you answer, then it would be easier for us to minimize the risk, which is the main goal of risk management. And interestingly, if you see the liability risk, financial risk, technological risk, as well as human health risk, ecological risk assessment, flood risk, all are basically the overall framework will remain same. So, in the concept of risk, quickly I would like to show you that they're taken from the Perception of Risk by Paul Slovic, 1987 in Science paper, where he has mentioned that here also this triplet structure you can see that here risk is a combination of different risk scenarios and likelihood, that what is the possibility and the damage vector. But at the same time, Kaplan and Derrick and many other people, they try to make it all complete in all respect. That's why this subscript C they put, so that all scenario could be considered. So, but if you see the climate risk literature, which is basically started from like 3 report of IPCC, and there they have mentioned that, and then I would say that after like third assessment report, during 4th, 5th and 6th, the definition of risk came multiple times, which is a combination of hazard, vulnerability and exposure. So hazard is basically nothing but the probabilistic part, what is the threat and susceptibility of a region. For example, if you compare Jaipur and Mumbai, we can say that Mumbai receives more rainfall, so it is obviously more flood prone than Jaipur. Obviously, that could be derived by sophisticated probabilistic analysis. Vulnerability is the susceptibility of a region to get affected. Maybe it may be social vulnerability, it may be infrastructure, it may be environmental, so economic vulnerability. So an exposure part for flood, basically, like analysis, we usually consider land use, land cover, and population. So these are and also the soil type. So susceptibility of a region to damage, but it has hydrological influences. So, but all these 3 components are uncertain. Even the vulnerability has multiple layers. You can see the same definition. You can see the report by Oppenheimer in IPCC AR5, and from that time onward, people started thinking about how to improve the definition of risk. Actually, it is basically these 3 ellipses are representing their confluence, which is represented at a spherical triangle, which is risk. So even through some adaptation strategies, through some mitigative strategies, if you try to reduce the vulnerability or some part of hazard by different structural and non-structural measure, overall risk would be automatically reduced. And here, Oppenheimer's group, they have shown that how socio-economic processes, different climate processes, natural and anthropogenic effect could affect finally adversely affect this risk triangle. But if you see the AR6, I wanted to show multiple definitions because every 5 years this definition are evolving. So here it is, instead of triplet, it is a quadruplet, where one more component, response, is included. So obviously, a type of complexity will always be there, and it is always be challenging to model this risk. So now I will show you, based on this definition of risk, how we can map this risk, I mean flood risk, as well as like forecast this flood risk, both. So for this mapping the flood risk at a local scale, since long, as I mentioned, we have been working on Mithi River basin in Mumbai, which is actually a kind of river, because as per Survey of India, there is a distinct source of water, so that's why we can say it's a river, but it's only 17.3 kilometers long, and a lot of urban settlement. Almost 50% population is a slum population, and also you can see that Mumbai modeling rainfall as well as flood is always challenging because high spatio-temporal variability, nothing worse, or even if you see the GFS model forecast, that will also not be able to forecast properly. Even if you run your work your own weather research forecasting model, then also you find it is difficult to calibrate. Abrupt change in the slope. If you see that here it's a hilly terrain, and here it's a Mahim Creek, which is confluence with the Arabian Sea, and here there is a drastic change in the slope. Also unplanned settlement, as I mentioned, as well as tidal influence. Out of the 17.3 kilometers, 7 kilometers, there is like a kind of tidal influence. Modeling that also is very challenging. So here in this case, we developed the flood hazard map considering the Mike 11, Mike 21 combination. 21 usually considers the tidal influence as well. But the problem is it's very sensitive. So if you see, if you have a very high resolution LiDAR data or maybe surveyed data, your simulation resolution should also be finite. And every time, if you change slightly your rainfall input data model, you have to recalibrate. So how to improve that? So then for the vulnerability part also, like around 36 indicators are there, like female population, population below 6 years, population above 60 years, illiterate population, then marginal worker, main worker. So these are all different vulnerability indicators. that we included. And I'm showing you this flood risk map in a very finer resolution. Though you can zoom it and you can see that very finer resolution map. So here it is called the choropleth representation, where this x-axis is representing the vulnerability, y-axis is hazard. So there are 3 color codes which are shown, but actually for risk there are total 9 color codes, which is basically increasing the spatial granularity of the map. It will become more contrasting because 9 different color codes you are right now you have. But for hazard part, if we can represent the hazard part with respect to time, so the areas which are getting flooded faster, so if we can identify that, based on that, we basically try to derive or try to replace this hazard part with some critical response time, so that evacuation and other activities could be prioritized. So this is also choropleth representation, and you can see for different events. So what was the severity? Everything you will be able to capture through this particular approach. And so this is basically, I would say, at the local scale. And at the local scale, like the resilience also. So not only a particular area, how faster it is getting inundated, but at the same time, how the water, logged water is getting receded from there. So that is also you need to identify. If the water is getting, basically removed from there very faster, we can say that area is more resilient. So there are multiple reasons which you can identify. So very finer resolution, you can identify those areas where where the resilience is very low. So finally, you have to find out high risk and low resilience zone. So that will be the real hotspot or true hotspots. So, but for the regional scale, Jagat Singapore, where we had to run some hydrological model, and inside that hydrodynamical model, so it is a nested kind of modeling. And here also around 1300 villages, and for multiple socio-economic indicators, and as well as the hazard map, which I mentioned. So that also we could derive. And finally, we disseminated this information in the form of a website. But for this regional studies, over this Jagat Singapore district, multiple things we did. So I would say it is a kind of, decision-making tool, which we handed over to NRSC, National Remote Sensing Center, in June 2018. And so this particular approach, now the OSAC, they are also trying to include. So also for this, but there is a transition from regional to national scale. So basically for that, some studies we did, but I could not, like here in this case, I won't be able to tell that whether it's a regional or basically national scale or at a country scale. But here basically we wanted to do a very comprehensive frequency analysis, so that like concurrent wind and the rainfall like extremes over entire India. So we did a regional scale analysis also, as well as a country scale, and we found some. It is a bivariate kind of like analysis, through which we could identify that how particularly the East Coast area, what is the distribution of this bivariate hazard map. But at the same time, one more important component which we focused, which is flood susceptibility. Few areas or some areas which are inherently flood prone because of the geomorphology of the region. For example, Mumbai. If you see Mumbai, geomorphologically Mumbai is flood prone, not only because of high rainfall. Okay, so that's why multiple geomorphological parameters we could derive from high resolution DEM, and that basically helped us to map the flood susceptibility. And there are multiple techniques to which not only the 3 components of risk, flood susceptibility could also be included, so that we tried to make. Yeah, sure. And for the global part, I have this only one slide where multiple land surface model and global hydrological model data are available at the coastal resolution. So how we can utilize it to run the global flood model, which is nothing but a simple hydrological routing model, which is called gamma flood. So you can see multiple runoff data set, and then after that, the gamma flood model, which will help us to run the hydrodynamic model for a large watershed or large basin like Mahanadi. Otherwise, normal, tube flow to B, so these are all basically, and also mine flood. So these are all hydrodynamic model will fail. So but please remember that global flood modeling for effective hazard and risk mapping, not for precise flood forecasting. So that's the important point. And finally, I would like to just tell two things here, that two things which I understood, that there are many, like regions in India where the balkanization is very prominent. If you take the example of Mumbai, basically flood data and other things are available with MMRDA as well as MCGM. So that should not happen. There should be more pluralization where all the data sets, etc., the civic bodies can share among themselves. In every assessment report of IPCC, you can see there is basically change or the definition of risk is evolving. So how to address this problem? So that also an important aspect. Also, I think in my opinion, there should be a community modeling scheme, as we have different, for example, like for the climate model, even for the land surface model also. That community model concept we need to bring. So if I develop a flood model, that should be available to all, and that particular model should be improved in future. So that is the thing. So community model concept we should bring in flood modeling. So traditional flood modeling may be difficult to address or to solve this global scale, regional scale, and local scale problem. Thank you so much.
I would like to take you, you have listened to a number of very distinguished talks up until now, and they are focusing on what kind of designs people have created to help in various aspects. I work at a meta level. I ask the question, how do people create those designs? And is there a method in the madness by which it is created? And is it the best way to do it? Is there a way of making it better? And so my work is research into design. I see design as the area of reflection and study, so that I can then help you to design better products and manufacturing systems. That's my email ID if you want to contact me. So when people say design, they mean all kinds of things. So let me set the record straight as to what I mean by design. This is the definition of Herbert Simon, which starts by saying that you start to design by something that you don't like. If you like everything, you want to design. And for instance, the fact that people go between 2 to 6 kilometers to the closest water source for picking up water and doing their daily chores, which is true for most of the global south, is not a great idea. Maybe water should be closer, maybe the roads are not safe, there's a lot of effort in cleaning pollution of the water source and so on. And therefore, you start planning as to what should the better situation be. Is it that you bring the water closer, make the road safer, make the cleaning process more or less effort intensive, and so on. And so once you establish the goal, then you plan for that change to happen, and you hope that it will happen when you intend, apply it as the way you want it to be applied. More often than not, it doesn't happen, and then you go back and do the iterations. The question is, can you reduce expensive iterations by learning about how to design so that you do it better? And depending on the kind of designer that you are, that's what the machine that you have designed. Again, my intent is not to show what a good design is. I'm saying what is fundamentally design. And design, as Herbert Simon spoke rather eloquently, is the planning for changing an existing situation into a preferred one. And designing is the way in which this is carried out. Both the goal is constructed and the plan is constructed to achieve the goal. And depending on the kind of designer that one is, one may be designing a power plant as a technical designer, or an educational system like a Montessori method, or an aesthetic systems like a logo, or legal and other systems. Now, design doesn't happen in vacuum. It is influenced by various facets. It depends on who is designing as to how the design will be. So people matter. Who is designing it for will matter. What kind of product is designed? The way you design a logo is very different from the way you design an aircraft or a dam. The kind of knowledge that you have and the methods and tools that you have makes a great deal of difference as to how you design. For instance, when people are making pyramids, they had no idea of soil mechanics. and that had its implications. And then within the organizational, ecological, and the economic setup within which you operate, and the way you utilize processes or not matter. So in other words, design is planning for changing, and it is influenced by all of this, and therefore it's multidisciplinary. It very much depends on which aspect of this you are working as a designer that will change the way you will see that side. And if you are looking at primarily engineering design, primarily the focus is in these areas. The things that you design, the kind of tools that you use, and the kind of processes that you use. Design research, on the other hand, focuses on these interactions. What's the nature of design and how does it get influenced by these facets? So if you're interested in the people facet of design, you may be looking at and drawing inspiration from anthropology, ergonomics, and so on. Whereas natural engineering sciences will be useful if you are designing products of certain kinds, or knowledge management software engineering if you are interested here, systems engineering, economics, theological sciences, and so on. So you draw on those, but also bring our own methodology to put it together to make sense of this. How do we develop knowledge to inform and support the practice and education of design? And this design phenomena, the understanding of design and its relationship with these facets, of course, are drawn from all of these human sciences, natural sciences, engineering sciences, depending on where you focus. Now, so the goal of design research is to develop knowledge with which we improve and inform the chances of producing successful solutions. So that already begs the question: what is success? What are the criteria for success? How is a successful solution created? In other words, what are the influences on success, and how well they are catered for at the moment, and how to improve those chances by developing new support to make it better and validate those support. And those are the four fundamental questions in design research, and that's where research methodology comes in. How do you ask questions? How do you ensure that the research is rigorous and effective and efficient? And so these are the kind of questions you ask. What's meant by your success? Each research is different. Are you interested in improving creativity? Are you interested in increasing reliability, or increasing reducing the cost, and so on? What influences success, and how can that be better supported, and will this support work? So those are the four fundamental questions. And many years ago, when we were struggling in doing our research as a young student in Cambridge University, we felt that we need research methodology that is of its own in this area, and therefore three of us put our heads together, Ken Wallace and Bhushan Desai and myself, and came up with a methodology, basically charting out these four questions. How do you identify the criteria for success? How do you carry out study to understand what influences it and how well? And then how do you improve that situation by developing prescriptive support, and then how do you test whether it works? And of course, you go back if it doesn't work. So essentially, you work like a scientist in the first two stages, then you become a designer, and then you flip back into a scientist at the end again, and then this process continues. So you wrote a book which has become very successful. I'll come back to that later. That's just a glimpse of that book. So what are my particular areas of research? That's the general area of research, but more specifically, I work in design creativity, research methodology, industry 6.0, design for sustainability, and informatics. I'm going to talk primarily about creativity and touch on research methodology. I've already touched on, and industry 6.0. So let's look at that. So what kind of questions we're asking? What is design creativity and how to assess it? Surprisingly, this is something that has not been sorted out fully, and we had to do some work on that. What influences creativity? How can creativity be better supported? And will or does this support work? So here is an example, and this is something that is important, so I'm going to spend a couple of minutes to explain. Fundamental to designing is an understanding of how things work, and flip side of that, how things don't work. And we developed a model of causality called Sapphire. It's basically a convoluted sort of taking words from these 7 constructs. So think of any systems, it has a bunch of parts and interfaces, and because of the way it is, it has certain properties, we'll call them modes. And when certain disturbances that are right, that come, let's call them inputs, then certain physical effects take place. If there are objects with inertia and if apply force, then acceleration happens, and so on. And as a result, phenomena take place, so exchange of energy happens with the surrounding, and change of state happens both to the surrounding and to the object of interest. And we might call them action. For example, somebody moving the hand very fast to your nose, which is a physical state change, however it may be interpreted as a threat. And once that happens, that state change may lead to change in the parts themselves. For example, you're heating an object and water becomes gas or vapor, and as a result, water ceases to exist. So parts and interfaces change, inputs change, and as a result, this process carries on until equilibriums are obtained. Now, what's so big deal about it? Well, if you look at it, designing primarily is a flip-flop between analysis and synthesis. When you are analyzing, say, let's say you ask a fairly basic question, how is electrical current generated? You might say, well, you have a circuit, it has certain material objects, and they have certain properties, resistance, closed circuit assumption, constant temperature. And then if I apply a potential difference, that's an input, then certain effect it gets activated, certain phenomena takes place, current flow, and I might call that a change in the current of the circuit and generating current circuit, so action. But I can flip that and say, what synthesis? Well, how do I generate current? That's a synthesis question. So I start by saying, what do I mean by generating electric current? From zero to some finite amount or from some finite amount to a greater amount. And having said that, I can then ask, okay, so what kind of phenomenon, maybe flow of current, how do I create phenomenon, maybe different ways, if I pick any of them, what is required from outside, and what are the internal organ requirement resistance to a circuit and so on, and then how do I embody them in physically so that can happen. And then I can go back and say potential difference, how do I create? Well, I can create that by maybe providing an electromagnetic induction, and then that's a phenomenon, how do I create that? Some input, and it goes on like that, right? So I can create more and more complex systems by putting these things together. Now, how does it matter? Well, it turns out that it's quite useful for assessing design creativity. So, if you look at those constructs, you talk about parts and organs, or phenomena and effects, or actions and state changes, we might say that if you are coming up with a new idea, and that idea is only different at the part and organ level, they are not particularly novel. But if they are more fundamentally, what do I mean by fundamentally? At the phenomena or effect level different. For example, I want to clean a place by hitting dust particles, and I come up with another one that also hits dust particles, but differently. As opposed to, let's say, vacuuming, then I'm talking about a phenomenological change in the design. So the idea is more novel. And if I can come up with a new action itself, for example, the first time machine, and of course it's heavily new. So I suddenly have a scale by which I can now place the finer points about how novel, not just novel or not novel, not binary, but a kind of ratio scale there. And so, novelty, when you talk about creativity, primarily you talk about two things. One is novelty and the other is usefulness. Now, what's usefulness? If you ask this question to people, it is very different from one person to another. So we came up with the idea that if you are using something, then it's useful. If it's not using, it's not useful. That turns out to be a very powerful concept. And then we divided that into three elementary forms. One is how important it is to people. Two, how many people use this, and how much is the effect of that use. And you can put it together in some scale. And then very surprisingly, we can multiply these two scales together and come up with a creativity measure. Now, how do we know all of this is correct? So, we looked at creativity literature and they said, well, the best people to judge creativity are experts. So we created a bunch of groups of experts. We gave them a series of products and say, tell us how novel, how creative, how useful these are, and huge correlation with what we created as scale. So that's the external validity of such work. Now, now that we know how to assess creativity, how do we improve creativity? So this is our primary interest, right? And it turns out that a major rule of how to improve creativity is that instead of one, you create as many alternative designs as possible and then pick the best. So the bigger this space, the better it is, or the more likely it is that you create something that is useful. So how do you create many alternatives? You looked at mechanical devices, for example, where things like a door latch, right? You turn it around, some lever rotates there, and this latch gets disengaged, for example, from the frame of the door, and then you can pull it and the door opens. Otherwise, it doesn't. So there's a bunch of multiple states that operate and transitions between them. But let's simplify. Let's say I want to press down and I want to retraction here, or I want to press down there and I want these two elements to go down. Or I rotate this and this element to go out and so on. So if you look at these elements, we can actually create a very simple description by saying my elements are only 5 lines. One element will only do this, another element will do this, one element will go perpendicular and parallel, and one will go skew. And by this apparently simple description, I can now describe something fairly complex. This one becomes that element, I push it down, it rotates, which is a pseudo vector, as you know, and that pseudo vector creates a sideways force, that's this element, and this is a combination of two translational elements taking the output here. So it's a combination, simple combination of this input. But now I can combine them differently. For example, I put all of this together, and suddenly I'm pressing it down, the wedge is going down and sideways, and this whole thing is coming out, a patentable idea. And in fact, this was created by a computer program that I wrote in 1980s. And then you can create multiple embodiments, you can create a tool around it, it will give you all kinds of ideas. What are you going to do with these ideas? You are going to stimulate people with these ideas so that they don't get stuck in one direction. They can look at multiple directions. And what happens, just remember that light blue is when people did not use the tool, and deep blue is when they used it. Every time, no matter what problem was given, when they used the tool, their fluency went up. Number of ideas that they created was substantially better. Now let's go back to this original problem. Dolax is not really pressing down one side and this side going in, right? I have to rotate, and then while holding that rotation, I have to pull it. Only then these things happen, right? Disengagement. So it's a bunch of kinematic states that operate and transition between them. That's how we create a complex device like this. So how do we create many alternatives in these multiple state mechanical devices? And that's basically what we do. So for example, you look at a bicycle drive. When you do forward pressure, it rotates and takes the bike around. When you do backward, it simply slips. So that's a multi-step device. Switch, off, on. And of course the latch that I talked about. So we did empirical study of design process of mechanical engineers, both novice and expert. They struggle to find even one alternative. Some do, but very rarely they are able to come up with a whole bunch of possible ways of doing it. So the key there is that there are multiple kinematic states and state transitions, and how do I modify my design such that you can transition from one kinematic state to another. And a lot of maths, I'm not going to all of that. There are some elemental functions for each of them. We have created modification rules. And with those modification rules, we can help anybody whenever they're stuck. How do I go from this kinematic state to that? So there are 10 rules that you can follow. Here are some examples, and that opens them up. Now, there are a lot of other examples. For example, I have an automated tool with which you can create feedback sensors and so on. But let me just show you one more and then stop there, which is the world's first tool on biological inspiration. So, Idea Inspire, and this is something we created with funding from ISRO. We wanted to make our rocket scientists more creative. And what did we do? We wanted to create, for example, very different kinds of solar antennas than the ones that are currently used. Idea is very simple. How do I use a glorified database of natural and artificial systems, described using that Sapphire model, how it works, and then when somebody comes up with a problem saying, I'm trying to solve this problem, show which ones are the most relevant solutions that exist in artificial and natural space, that I can simply show them to get inspired. And by this inspiration, they will lead to multiple designs. So here, for example, is a non-vegetarian plant called Venus flytrap, and it describes Sapphire model is used to describe how it, for example, traps it and utilizes the essential nutrients that it doesn't get otherwise. Or a friction disk, which is, as you know, a continuous gearbox that you use for.
Prof, 2 more minutes.
Sure, we're getting close. And we did that evaluation, multiple designers, they come up with ideas on their own, and then when they got exhausted, we introduced Idea Inspire. There is a 165% increase in their ideation phase. Last two elements that I will show very quickly. One is IRC Smart Factory. In 2014, with Boeing's funding, we created India's first smart factory. And then with MHI, Ministry of Heavy Industries funding, in 2019, we made it full scale. So, and it's the first Industry 5.0 platform, you will see why. We ask these two questions. How do we use smart elements to empower human labor, to enable greater productivity and so on, as well as what's the usual idea of Industry 4.0, how do I use general automation, replacing people and so on, for making that happen. So we created two platforms. One is the regular automation-centric platform, and the other is a frugal empowerment-centric platform that might be useful for the MSMEs. So if you look at this Arduino, it's basically a factory. In every factory, there will be incoming inspection and storage, outgoing inspection storage. Some machines and areas where movement of materials will happen and transformation of materials will happen. So if you look at these three fundamental things, there are two copies of that. This is the automation centric one, where the machines are data intensive. It's a 5-axis CNC or a metal laser router and so on. And they have their data capacity already. There is an AGV or a cobot or something that moves materials and so on. Whereas here, it's people that move materials, or a regular crane that does. And a manual legacy machine or a bunch of them that does the one. But these blue lines are important. They are all connected. We are taking data from all of them, putting it together, making sense of this in an analytics station. And these two can be connected to each other. So you can create all kinds of hybrid factories. A little bit of automation, a lot of manual, other way around. And with that, we can look at how do they play out in terms of quality, safety, productivity, resource utilization, and so on, including sustainability, which has been the topic of today. So this was inaugurated in 2019. That's a digital twin of the factory. This is the heavy industries secretary using that digital twin to see what's going on. And that's a combination of automated guided vehicle and a cobot to do both dexterity and mobility. And that's a digital twin in more detail. You see the regular wire EDM, laser router and so on, the automation centric one, but also the legacy area with regular layers and other things. And the multiple layers, edge layer all the way to the execution layer. Last one before I close, and that's IIC debox. Another question is, how do I democratize design to school children? And people have been talking about it. And one thing we did was that we looked at, for example, the way in which training happens right now. So if you analyze the CBSE exam papers, there's something very interesting that turns out. You know about the revised Bloom's taxonomy, right? So that basically says what are the cognitive processes that we should train people in. And these are the cognitive processes. Remember, understand, apply, analyze, evaluate, create. And if I look at the exams and the kind of questions they're asking, 34% is about remembering, a third of it. 46%, half of it is about understanding, 13% applying. Hardly anything in analyzing, evaluating, creating. So not surprising that things like critical thinking, creativity, and problem solving are not touched. And so this is where design thinking can be useful. So what we did was, we basically created a design thinking model called IIC design thinking. IIC stands for identify, ideate, select, and consolidate. And then we created a game around it. So basically, identify requirements, ideate solutions, consolidate solutions, select the most promising one, and go through that loop. So this is a game through which basically a board game that they play and they understand how design thinking happens. And we played it in over 60 schools. And this was the very first one, Air Force School Nepal. And they created very interesting designs. For example, school children went around and looked at their own habitat. They found out that some of the toilets are too high for them. So what they came up with a brilliant solution. They created a ramp and they put it underneath. Now, depending on how tall you are, go to that portion of the ramp and then you are accessible. Beautiful ideas. And that already creates the mindset. So finally, to say, okay, what's the impact of that? DRL, that methodology I talked about, is already taught in 10 countries. Very highly cited. Assessments are used widely. Support tools are used widely. For example, Arya Inspire is customized for ISRO and IMI Cornelius. Sapphire model is used by Rolls-Royce for aircraft maintenance knowledge structuring. Pratt Whitney in in-flight service manuals. ISRO for lunar rover platform design. And the debox already has been played in 60 plus schools, and actually 50 colleges, engineering colleges have been trained in IS design thinking. And I have been blessed with being fellow of the Design Society, Design Research Society, honorary fellow of the Institution of Design in the UK, and ASME 2025 Technical Outstanding Design Special. Only one is given every year, and this is the first time it comes in Asia. So that I'd like to thank you.
Hi everyone. So I'll be presenting the work that we have been doing in the area of quantification of pollutants in water and the mitigation measures. So here specifically I will be talking about emerging contaminants or the contaminants of emerging concerns. So these are different from the conventional parameters that we talk about, whenever we are addressing any water pollution related issues. So these are the chemicals that we use for certain other purposes, but after that use, it ends up in the wastewater, and ultimately gets into the water cycle, and these are highly persistent in nature. So it's very difficult to remove this. So if you look at the different, there are hundreds and hundreds of compounds present under this category. So mainly the organic contaminants, if you are looking at it, there are pharmaceuticals. So that means the medicine that we consume. Then the personal care products, that means the ingredients that are present in the day-to-day whatever products that we are using. And some of these are actually having the property of endocrine disruption. So that means their structure will be similar to any natural hormone. So if it gets into our body through any of the exposure route, so that means when we are consuming water or consuming food, or if it is there in the air, if we are inhaling it, or if dermal contact, let's say when we take bath, or through contaminated soil, if it gets into the body, so body will think it's a natural hormone and it start doing that intended purpose. So these compounds are present at very, very trace concentration. So that means micrograms per liter to nanograms per liter. But due to their persistence and our conventional treatment plants are not able to remove it entirely. So there is a chance that it will be present in the water that we consume. At very low doses, we are getting continuously exposed to this. So what we are trying to do, so these compounds are not regulated. So if you go through our BAS training standards or CPCB discharge standards, so these compounds are not listed there. So these are being unmonitored. And we mostly rely on the data published by Western countries. But the chemicals present in our environment, that is heavily dependent on the region-based consumption. So it is of utmost importance that we should identify the contaminants that are present in our environment, which are persisting in our environment, identify those, and then come up with treatment strategies. So if these are present in our water, upgrade our treatment facilities, or come up with innovative treatment techniques to remove those. And if these are present in our receiving water bodies, which will be used for drinking water production, then we should have adequate treatment technologies at the water treatment plant. So if we compile the results, the different studies published, so we'll find that surface water, groundwater, so all are contaminated and the concentration levels are also mentioned. But here the major limitation is that if you have ever quantified any contaminants, so you will know that we need to procure those standards and we need to plot a calibration curve, and then we will test an unknown sample and identify the concentration. So here the labs are mainly limited by the number of standards that they have. But are we interested to know what are all the compounds present in our water sample? So if it is possible, how to do that? So that is where this non-target analysis is of high importance. So what is this do? So here we have to rely on high resolution mass spectrometer. So we inject our samples there and we impose certain criteria, we run some algorithm and then filter out the chemicals. Okay, so there are two categories here, suspect screening and non-target analysis. So suspect screening means that, okay, we will have a defined set of chemicals and then we will look, okay, these are present, even if we are not having those standards with us. Non-target means there are endless possibilities. You go through each and every compounds that are getting detected and see how it behaves in how the MS data or how the MSMS data is there. How can you confirm or can you at least do the semi-quantitation? What is the relevance of this? We can actually come up with a priority list for our region. Okay, so we can list it. So we are getting certain, let's say we are getting 100 compounds. We can prioritize it based on its risk, its persistence, its bioaccumulation characteristics, and then whenever there is a need to come up with the regulatory standards, so these data is going to be highly important. So this is just a summary of the study that we have conducted by analyzing the sample from Yamuna River. So we adopted this non-target approach and you can see that so we are able to identify 658 by this non-target analysis. So if we go with the normal targeted one, we will be restricted by the number of standards. Let's say it depends on, let's say 20 standards we may have or 30 standards. But here you are going to get the entire picture. So how many compounds are actually there and go through the list. And then we will be able to quantify that. As you can see here, so most of these belongs to the pharmaceutical category, and then you can see personal care products, some industrial chemicals, some pesticides. So we have also further categorized into which kind of pharmaceuticals these are, and even the pesticides. Okay, so the kind of pesticides that are present in our water matrix. So as you can see here, so among the pharmaceuticals, many of these belong to antibiotics category. So that is another critical challenge. So when continuously antibiotics are getting released into the water body, the microbes become resistant. So you might have heard about the antimicrobial resistance. So how it is affecting. So it is whenever we are talking about the health effects or the different risks that we are perceiving in the near future. So antimicrobial risk, the proliferation of antimicrobial risk is also one of the major concerns. So this actually gives us the current scenario. So how far it is polluted. So now comes the mitigation measures. So one of the major sources of these contaminants are obviously the wastewater. It could be it could be there in our municipal wastewater, and depending on the raw materials used in the industry, it will be there in the industry wastewater. And if you go through the regulatory standards or the MGP norms, we talk about COD, BOD, nutrients and the coliform. So here what we are trying to do here is that we focus on certain advanced biological treatment unit and further try to improve the quality of treated water. Because there is, we know that we are facing water scarcity. It is high time that we start practicing the reuse of water, treated water. So in order to achieve that, we need to modify our treatment system. So one technology that we have tried is that biological nutrient removal. So we are trying, in addition to BOD, we are also trying to remove the nutrients in water. And we optimize the condition, and we also try to understand what happens to selected pharmaceutical compounds in this treatment system. So this was actually employing different redox conditions. So one advantage is that when we are trying to remove nutrients from wastewater, the kind of operational conditions that we are employing there, that is indirectly helping to remove some of these chemicals as well. Okay, but as you can see there, due to the exposure to these pharmaceutical compounds, it is highly affecting the microbial diversity there. So only the microbes that can become resistant to these compounds will only remain there. Then we also studied what will happen to another advanced technique, that is the membrane bioreactor. So here we found that it actually contributes to significant fouling because it is creating stress to the microbes. As a result, the fouling potential. So there are certain chemicals that are secreted by the microbes that enhances the fouling. So these compounds act as a trigger. Okay. So what is the advantages of doing this kinds of tests? Because all our STPs currently are there, they are getting, all these contaminants are getting passed on to these treatment units. So once we understand that, how the performance of these technologies are going to be affected, we can accordingly adjust the operational condition. So in addition to getting the wastewater that can be reused for certain other purposes, we are also able to eliminate the emerging contaminants from there. So here, this summary where we have considered 3 emerging contaminants. So these are basically the iodinated X-ray contrast media. So
Can I
basically,
request you to conclude the next 2 minutes?
so this is just showing you how far it is getting removed comparing to different treatment techniques. Okay, so just to quickly summarize, so what should be our approach? Whenever we talk about safe water or one type, what should be our current approach? Because one or the other way we are going to reuse the wastewater and these compounds are going to be accumulated there. And you know that we don't have sufficient infrastructure, only 30 to 40% of the wastewater only is getting currently treated. And what happens to the remaining wastewater? It is getting, it ends up in our water bodies. So these kinds of studies are highly significant now, so that we identify the list of contaminants. So our regulatory agencies will be able to come up with the standards, and we can also adopt the advanced treatment techniques so that these are getting removed at the treatment plant itself. So with that, I would like to summarize, and I would like to express my gratitude to INAE for giving me this opportunity, and and I would like to thank my research team and the support received from IIT.
In general, traditional and thumb rule based and primarily iterative. But as we all know that concrete is a multi-scale material and it also has different phases. So the phases change during time and also with respect to different length scale, the phases also changes. So the conventional use of macro mechanics to understand this heterogeneous and multi-phase material may not be sufficient. And there is a need to use nanomechanics and micromechanical approach or understanding the material from the fundamental length scale for efficient engineering. So towards this we have carried out some of the works, and I'll be taking you through some salient works that we have carried out. So firstly we have tried to understand what is the relationship between the structure, which is the micromechanic or the fundamental structure of the cement based material, and the macroscopic property. So we know that the most fundamental phase of concrete is calcium silicate hydrate gel. It is called as the building block of concrete. So we try to use molecular dynamics approach to understand how the structural atoms and the structural mechanisms in the CSH affects its property. We all know that concrete is strong in compression and weak in tension, and we assume that this phenomenon comes from the macroscopic phenomenon. Whereas while studying or understanding the material at the fundamental length scale, what we could observe is that this difference in tension and compression could be identified at much lower length scale. So this gives us an idea from where the engineering has to be carried out for us to reach to the goal that we are trying to address. And also we have tried to use molecular dynamics simulation to identify the best means of nano-engineering the cement composite. So for incorporating nanomaterials, the nanomaterials, because of its particle size, it has high van der Waals force of attraction. So it cannot be directly added into concrete. So there are some means by which the materials has to be segregated, otherwise it will remain agglomerated. And to do that, there are some chemicals called surfactants that are to be added. Whereas concrete itself being a reactive material, so these surfactants should not affect its property also, whereas it should also disperse the nanomaterials evenly. So we try to do some compatibility studies with a few kinds of surfactants along with the CSH, and try to see some are not compatible with CSH and some are really compatible. And also try to see which kind of surfactants are efficient in dispersing the nanomaterials. So both should come hand in hand for efficient engineering. Then from the nanometer length scale, then we try to move on to the micro scale, wherein the cement hydration models were used, and in the cement hydration models, just with the help of the same image of the cement powder, we can understand how the hydration phases vary with time, and based on the hydration parameters, how it changes can be studied. So from that we try to build in a 3D microstructural model which can be used in a finite element code, and it has all the distribution parameters with respect to space, and further understanding any mechanical property is possible from this finite element domain. And also the properties that we obtain from the nanomechanics and the micromechanics, in order to realize what it happens in the concrete scale. So there is a process called upscaling, or some analytical homogenization is being done. So these properties are translated from CSH phase to the cement phase, and there to the cement mortar, and then the concrete. So in order to have a particular performance at the concrete scale, it is possible to go to the fundamental length scale, engineer there, and then see realize how it has translated to the concrete length scale. So using some of these fundamental approaches, we have tried to develop a hierarchically engineered cementitious composite. So wherein this composite has reinforcements at 3 different length scales, from starting from a nanometer reinforcement, which is a carbon nanotube. So then slowly going forward, we have used some microfibers, and we could also see that due to synergistic effect between these two scales of fibers, how the properties are enhancing multifold, and also to understand how this fracture process changes due to the synergetic fiber incorporation. We have also used some experimental tools digital image correlation. Also, we have identified a method wherein from the DIC images we can also identify, in fact, quantify what is the size of the fracture process zone. Then moving from concrete, we have also done some studies on FRP composites. So basically, these FRP composites are used more in repair industry for the concrete structures, and nowadays there are many FRP based components or the structures which are being realized. So again, to understand how what phenomenon takes place in this FRP composite and how different environmental degradation factors affect these structures, FRP materials, we have done some fundamental investigations. So basically in FRP composite, there is a chemical or a adhesive agent which is called epoxy, and these epoxy undergoes degradation with different environmental factors. So we have tried to understand how these environmental factors affect the properties of epoxy polymers. So for which we have done some fundamental simulations and also some experiments at different length scales.
Sindu, if you could conclude.
Yeah, sure. So from these fundamental investigations, we have come up with some of the technologies. One such technology is the piezo-resistive cement-based composite. So which can be used as an embedded sensor. It has a self-sensing capability and can be embedded into the structure, and it can also work as a sensor. And also we have tried to use this multi-scale reinforced composite to enhance the seismic performance of beam column joints, and also retrofit material, cement-based material, which has a very high strain hardening property, or the ductility index is very high. So these are the outcomes of the work. So in terms of technology, and we are also working closely with industries to give industrial solutions in terms of assessing the structural adequacy of the structure, and also to enhance the capacity or service life of structures. So in order to summarize the work, so we have been carrying out studies from the fundamental length scale using the bottom-up approach to understand and engineer the materials which are used in infrastructure. So this is the work that has been carried out. Thank you.
We are talking about ecological risk assessment based site-specific remediation standards and strategies for critical economic areas. So my journey started while I was doing my PhD, and I did multi-objective optimization of hazardous waste management system about 27-28 years back. And when we say multi-objective, one objective was obviously money, cost. We have to optimize in terms of minimum money, we have to manage things. But another objective was environmental risk. We have to do the things with minimum risk to the environmental things. So there I started developing risk functions to take care of the waste management related issues, be it handling of waste, hazardous waste, be it transportation of the waste, be it treatment, be it disposal, and so on and so forth. So my journey started there, and I moved subsequently to IIT Delhi as assistant professor, and I think I was about 4 to 5 years old in IIT Delhi that time, and Central Pollution Control Board approached us for developing site-specific standards for a particular site which is in Kodaikanal, Tamil Nadu. I'll come to that part slightly later, but before that, the kind of things which I have gone through in doing this research and developing this type of systems, I'll take you through. So, in order to define the critically polluted sites, we are talking about wherever pollutant levels are much above the threshold and they are threat to human health as well as or ecosystems. We are talking about such sites. If you look at public interest litigations and court cases, we have 200 plus sites in India. Many more which are not under litigation. So if we apply a rule of 1:30:300, you can imagine that number of actually contaminated sites in India. There are too many in numbers. They include legacy industrial activities. Sometimes industrial waste was discharged in past and now no more, but these sites needs remediation. Abandoned mines, accidental releases, and so on and so forth. So we are talking about persistent accidents of pollutant concentrations at those sites. And obviously there is a toxic and hazardous materials we are talking about. I'll take you through only heavy metal related aspects in this because it will be then 15 minutes, 20 minutes, 30 minutes presentation. So I'll just limit myself there. And remember one more thing, nature has exhausted its capacity to assimilate those toxins. And it is much beyond that, therefore we are saying that these are critically polluted sites. Examples are well known, pollutants are plenty and different categories, we will only focus on heavy metals. So this is the methodology we adopted. We did sampling of water, sediment, aquatic microfluids, including air, etc. etc. We calculated the trace amount of metals in the vegetation and so on and so forth. We did sample collection, analysis, statistical rigorous analysis of those values, and then finally based on the receptor data we tried to do human health and ecological risk assessment. So this is the site in Ghaziabad, which is full of different type of industrial activities, and I'm just trying to show some of the sampling sites which are scattered. The whole of the Ghaziabad is there are a lot of industries, various different type of industries. We did a lot of sampling of soil and sediment in this case. So I'll again focus soil and sediment in this case. I'm avoiding surface water deliberately just to keep things in perspective. We did metal fractionation of the sediment and we analyzed several types of heavy metals: copper, lead, chromium, cadmium, nickel, and so on and so forth. These are just some sample output results what we have done. So this is part of the data collection from the soil and sediment. We moved on to do some more detailed calculations in terms of finding out what is the kind of enrichment factors. How over the time soil is holding those toxins, which is likely to create later on groundwater problems, subsurface migration of the pollutants, and then surface water pollution. So, and then we tried to understand this with the help of a geo-accumulation index, wherein some base metal like iron, how much is it, and then and also we compared with the some sites which are not polluted, and then accordingly we try to see relatively where are we in case of our samples. And we did detailed calculations about the safe limit which is possible for soil and sediments to have. Interestingly, if you will check the Pollution Control Board related guidelines and norms, they do not say anything about soil and sediment. How much is acceptable concentration of heavy metals in soil and sediments? They talk about water, they talk about air as a media. So we try to do a lot of back calculations with the help of fuzzy logic approach, and we try to arrive at what is the possible safe limit in the sediment and soil. A lot of back calculations we did in this case, and this was done with the help of two as a major issues which heavy metals will pose. One is cancer related risk, second one is non-cancer related risk. some metals are quite prone in terms of causing long-term chronic exposure will give cancers. Some will give you only acute exposures. So we did all of that calculation. In this, important thing is to consider the intake through various ways. It could be dermal contact, it could be ingestion, it could be inhalation, and many other things. Also, it includes when the metals will become part of the food chain, and then it will become part of the human food which we consume, either through directly, if it is like vegetable, etc., or indirectly if it goes to aquatic ecosystem and it becomes part of our food chain subsequently. So we did this probabilistic analysis and we tried to see what is the probability of causing cancer and causing non-cancerous diseases with regard to individual metals first. Subsequently, which I am not showing here, we did the calculations for bioaccumulation and biomagnification of these metals, and also we tried to see what is going to be the synergetic effect. If there are more than one metal present simultaneously, sometimes 1 plus 1 doesn't become 2. In case of environmental ecological toxicity, it becomes 3, it becomes 4. So two metals together may be synergetic and they combinedly affect some of the human organs in very synergetic way, that is 1 plus 1 is more than 2. I'm just trying to say in simple language. So this was one. Carrying forward to this, learning from this experience, we got a proposal from Ministry of Environmental and Forest and through CPCB that we need to set up standards for a mercury contaminated site in Kodaikanal, Tamil Nadu. If I go to the story of that, there was Ponds India Limited which was manufacturing mercury based thermometers from back, and accidentally they will break some of the thermometers and mercury will spill. They had 20 acres of land and there was close to 6 tons of waste every year. So 6 tons of glass waste they were selling at scrap. In one fine day they found that the person who is taking this scrap, 6 workers died due to mercury poisoning. And it was a big news in the media and so on and so forth. NGOs came up with a lot of demonstrations that this should be cleaned up completely. Meaning of cleaning up was that they should go back to zero level of mercury, which was not possible. So we did the exposure scenarios for this site for the mercury. We did 3 calculations. One was for human health, second one for ecology. So in terms of ecology also we tried to learn all the exposure routes, the worst case scenarios, behavioral patterns, etc., including if some of the animals etc. are using the fruits etc. grown in that area. So this is the metal concentration of mercury, you can see very highly contaminated as against Fe. And then we calculated for children, women, etc., found that this gives us a site-specific target limit of 28.01 microgram per gram, whereas when we did the detailed calculations for ecology, we did for 2 species. I'm showing the result for only 2 species. So we did it for quail, which is prevalent in that area. We found 36.09, which is safer than the human health. However, when we look at sparrows, it was much less. It was 22.42. So ecological species were much more important than even human health in this case particularly. So we recommended 22.42, which was adopted as 20 to make it slightly more safer. NGOs went happy, the industry went happy that yes, we can treat it up to this level. So this is the summary. We applied then this methodology for several places, and subsequently learning from that experience we developed CECs, which is an index which tells us that which areas are critically polluted. So we did this study for 83 areas in the country and we found 43 areas are critically polluted. I'll stop here. Thank you.
I will focus my studies on hydropower particularly, and focusing on hydropower, which is one of the areas where I am working still. And why hydropower index? See, in somewhere 2005, we got advice from the Ministry of Non-Renewable Energy Resources that the hydropower which are working in the country are not very efficient, and let's monitor their efficiency. And then only they have started one subsidy also, that if they cross to some parameter, say 80% or more efficiency, they will give some subsidy. So then this responsibility was given to the IIT Roorkee. So we formed a team, and I'm a founder member. My responsibility is to have the hydraulic power measurement. And then in the team we are having some persons from the electrical power measurement, and then also some civil persons. Then we have tested around 130 small hydropower plants all over the India, and advised them to improve their efficiency and conducted tests to do the efficiency. And particularly this thermodynamic method, which is done generally by some fine country experts, we have developed this expertise also here, and I have conducted this study in 2 of the power plants. Then we started, when we learned that hydropower plant problems are there, then we started research in operational and particularly sediment erosion problems, which are because of the Himalayan region. And we have done some collaboration with the foreign universities also, because earlier we are not having facilities. Now we have developed the facilities, so we are working with our facilities. I will share some of my work which I have done with these universities also, and also share some work which I started on my own in my institute. And then I also inducted in 2019 as an executive committee member of IHR division of Hydraulic Machinery and System as a sole representative of India. So now we are having a representation there also. Now this is a typical hydropower. This is not the only one type of hydropower. This is only the dam-based hydropower plant, where we are having the turbine and the tail race and some water is coming with some hydraulic power, and then it goes to the generator and the transformer and then the grid. My focus is the turbine particularly, because I am a mechanical engineer. And we have seen that nowadays also a lot of penetration is there because of the solar and wind energy, which are the intermittent form of the energy. And that power demand is to be balanced by the hydraulic gauge-based power plant. So when we go to the testing of the power plant, we find that there is a frequent power grid failure, and there are some frequency excursions also. And because of that, we feel some vibrations. Okay, because of the potential variations. And there is a notion that each start-stop reduces 15 hours of the life of the runner, but no data are available if you do the load ramping to balance the power because of the solar and wind intermittency, then what will happen? So then we started that we will do some study on the transient operation of the power plant. Okay, particularly this is true with the small and medium hydropower plant. Those who are not captive category. And we have started this investigation. So what we did is we have fitted some sensors, miniature sensors on the runner, and then some sensors on the dart tube. They are the pressure sensor to monitor the pressure. We have maintained some special arrangement to measure the velocities also in the dart tube cone, which is starting just after the runner. And here is the plane where we have measured, and this is the center line where we are monitoring the velocity. Okay, so we have measured the full flow field, pressure and velocity in the dart tube, and pressure only in the runner, and in some various space between runner and the guide rails. Okay, when we see this is the pressure P12, P72, and we have named there here. Okay, and one is the suction side P71. So these pressures, we have seen that these pressures, when you reduce the load rejection, then these pressures will be fluctuating. And if you stick to a small window where the frequency is around 1 kilohertz, there you will find that there is a lot of fluctuations over the mean pressure. Okay, and the pressure will give you some frequencies in the runner which is equal to the guide rail number, and in the wellness space which is equal to the runner weight number. And now if we see the velocity variation which we have seen using a particle image velocity metric system, they say that from high load if we coming to below BP, there is some stagnation pressure forms, and that stagnation increases decrease, and that gives a phenomena of vibrations. One is the plunging component and another is the rotating component. So plunging appears before and earlier, and then the rotating component, and then we go to the part flow, the problem will become more and more severe. And same thing if we are going to load, in this case, the transient pressure loading in case of load rejection is 2.8 times larger than the pressure fluctuation that in the steady state. So this also gives a loading on the runner. Now, if we go to load acceptance, it is 36% to 100%. Then we are having again a separated flow will converge, and here this stagnation region before reaching to the VP will diminish, and then again our flow will become full flow in the draft tube. Okay, here again this transient pressure loading is little lower. It is 2.1 times compared to the load rejection of the steady state condition, but still we are having transient loading here. Now, if we see the emergency shutdown means suddenly if there is a grid failure, then suddenly it will go down. Then if you are having an emergency shutdown, then it will result in the total load rejection, and that gives you more pressure fluctuations in the runner, and particularly in the vaneless space, it is 200 times. Okay, 200%, so that times. Okay, if we see the pressure fluctuations, then you see around the mean line, the BP, runaway, and this runaway, which is for runaway from 9.98 degree, which is the BP condition. This is the full load condition. So full load condition, you are having more pressure fluctuation. Either it will be vaneless space, blade suction side, or runner side, or the draft tube. Draft tube will be having the minimum fluctuation will be around 0.02 around the mean line. So that gives you that you are having the pressure fluctuation in the vaneless space, which is highest at around 1.8 to 2.2 times of the BP condition. So if you are running the turbine at the BP condition, then your runner line is much more higher. Then you are running it to the runaway condition, or you are going frequently to the runaway condition because of the frequency excursion or start. That's why your life will be reducing. Okay, so with this again, we have seen that if we go to proper shutdown, sometimes you are required proper shutdown, which will require sufficient time, then your pressure fluctuations are not very high, but a formation of vortex load will form when you go to the high load to the BP, and after the BP again you are having the vortex formation. So in that shutdown also will give you the vibration because of the formation of the vortex load. Okay. Similarly, if you are starting up, then your vortex load will form earlier, and then will diminish as you come to the BP, and then you are having a proper flow condition. So there will be no vibration or just either in the power plant where you are standing or on the run. Okay. Then this gives rise that if you are having a part load condition, then why we are having a vortex load formation? That we have seen that if we are having a BP condition, then flow is all through the turbine. But if you are having a part load condition, then you are having a swell component, and that giving you zero velocity near the center. Okay. So now we have again started and made some measurements of the draft tube and found that this vortex load frequency will be formed at 0.28 times of the normal runner frequency. And if you see this vortex load formation, then we will see that there will be a zero axial velocity zone will be formed, and this zero axial velocity zone will, if we can diminish this zero velocity zone, then we can overcome this vortex load formation. So we built a special test rig where we are having a turbine, and in the turbine we are having a method of injecting the water jet as well as injecting the air jets from the surrounding, so as that we can break that stagnation zone. Okay, this testing was not earlier, so earlier people were doing with the swirl testing. Now we started air jet injection, and this is the percentage of water jet as a percentage of main flow, which will go up to 2.5% maximum, and we found that we are able to diminish this peak load peak pressure pulsation by 73% in case of purging, and in case of rotary we are going diminishing around 65%. So we are diminishing their damaging effects a lot. Now if you see this spectrum analysis also, this is the RVR frequency which will be diminishes if you go to 0.5%, then 1% and 1.5%, you will see there will be no RVR frequency are being seen here. Okay. Now if we see the pressure recovery, the pressure recovery in the drop tube cone is maximum and it improved by 163%. Even the turbine efficiency will improve by 2.96%, maybe around 3%. Okay, by only the water injection. Okay, if you go to peripheral air injection, then you will get diminishing of the pressure pulsation by 50% or 60% by in the pulsing as well as in the rotary pulsations. Okay, if you are going to the combined air and water jet injection, even 1% water injection and 0.25% water injection 0.25% air injection will diminish your all air injection. But if you see the literature, then the existing literature says that you have to inject around 8 to 13% of the main flow water to diminish this air jetting. We have especially designed the nozzle to come to the 1 to 1.5%, and even we are able to improve the efficiency. Now, our key observation is that runner life is not only affected by the start at top, but also by the load ramping. Okay, and it is equally affected by both the things. The maximum pressure rise will be observed in the weightless space, which is about 200% during shutdown and load rejection, and transient pressure loading during load acceptance and load rejection is around 2.1 to 2.8 times, and vortex flow can be mitigated by very small amount of the air injection or the water injection. You need a proper method. We have shown that 1.5 to 2% or 1 to 1.5% can do it. The water injection can improve the pressure recovery. Combined can remove both the some more of the work I just listed. It is some aerodynamic profile of the loco, some impeller development for loco. This is the modified guideway we have installed in one of the power plant to reduce their erosion problem, and there we are successful in that. This is the rig we have patented for measurement of the erosion. And thank you.
This is a project that we started way back in 2020, just when COVID was about to spread. And this is our team. Our team consists of something very peculiar to academic institutions. We have 2 lieutenant generals who are a part of this team, which is not something that is common in academic institutions. And that is how this project was conceptualized and taken forward. And now, if you look at artillery shells, we always want a longer and longer range, and that is something that is always desirable by the military. Now, how do you get range? If you do very simplistic calculation that you learned in high school, what was the standard that you take out the atmosphere, you will get V square by G, and you will find that the range from a Bofors gun will go to 72 kilometers, whereas the actual range comes down to 24. So the drag plays a very crucial role in this, and drag reduces the range. Now, what are the methods of mitigation, or how do we overcome it? One is increase the barrel length. We've done that in the past. If you look at 39 caliber guns, 39 times the diameter inside. Simple listing. And we've gone to 52 caliber, that is with attacks gun, very recent one. And increase the propellant loading, that has also been done in attacks gun. It is a very large chamber volume, that is of 25 liters. And rocket assisted projectile and base speed. All this has been done. And we have reached the limits of where we can go with articulations. So we looked at something that is possible with this ramjet. Now, why ramjet is, if you look at what comes out of the gun, it is usually more than Mach 2. Most of the guns, and it goes up to Mach 3 in some of the guns. So when you look at the Mach 3, that is very good this thing to have, starting point to have a ramjet operation. And if you look at what are the challenges, most of us in the missile community will think, oh, that is very easy and all that. But in a gun, the biggest problem is G loads, which is 15 to 20,000 Gs, pressures, which is of the order of 3,700 bar, and RPM spin of the order of 18,000 RPM. So with all this, we started. And when you look at ramjets, most of us will think of BrahMos configuration, which is front-ended. But with a general on board, we had difficulty in pushing it through because he said, I don't want to throw a grenade to 100 kilometers. What's the point in throwing a grenade to 100 kilometers? Because the explosive content is going to be reduced. So what we looked at was an alternate design which has not been thought of anywhere else. That is, we had base fleet, we took it out, and we made something which is a side entrance or a submerged entrance, as it is called in this literature. So air comes in, mixes with fuel, and burns. So when we look at it, it is an existing shell that has been modified to accommodate this ramjet. So that base fleet unit is taken out and the ramjet unit is attached. Let's go to the end in this interest of time. So there is an increase in the length of the projectile also, so balancing and other things needs to be taken care of very seriously. So when you do such kind of design, you will have to do first the aerodynamic design. Then we did that. Then you have to do also a propulsion design, which we did. We tested the propulsion design. In fact, IIT Madras is the only institution that has a license to make its own propellant. This was not thanks to me or anything, but it was thanks to my predecessors, Professor Krishnan, who was there earlier, who set it up way back in the 90s. So we can make our own propellants. And then what we next did was something very interesting, that is combine aerodynamic and propulsion. That is, put this in an open jet facility and test it. That was also successful. As you can see here, there were two places where it was held, and as usual, it will have a different drag on both the limbs. But the good point is the drag is getting reduced as the propulsion system is switched on. So with this, we went ahead because you are making a new projectile for the Indian Army. You go and ask them for a gun, they'll say, how can I guarantee you a gun costs a lot? How do we do this? So in order to break the jinx, we said we'll make our own gun. And we made this gun, and the Indian Army was very nice to us. They gave us land in the School of Artillery to build this and put it up there. So with this facility, we made our small projectile 76 millimeters. And when you start looking at real life problems always throws up something that you never anticipated in life. And we had spectacular failures, wherein projectiles failed, broke into pieces, like one of the above. But with a lot of effort, we were able to overcome that. We must have fired at least 60 to 70 such projectiles in order to experiment and understand this. And we were able to get a mass of 2.1 kgs to 500 per meters and show that the ramjet is active. That was one of the key things that we had to do, and it comes out clean from the gun and all. So after doing that, we then looked at the full shell, wherein if you take this basically, this is the ramjet. The weight increased, and we had to 3D print this ramjet, completely 3D printed. And this is the first time in the world that such a existing shell has been modified with a ramjet and tested. We went for trials in Balasur somewhere in January of 2024. And first day, first show was a very nice thing. It came out all clean and we were all very happy. But happiness doesn't last long. And as you can see here, the ramjet where the threads are applied, that broke off, and it was a very, very challenging problem to overcome this. And but the good thing for us was it came out clean from the gun, and the internal ballistics, as they call it, was very good. The ramjet was also activated. In fact, we had a small fire set up in this thing because of our ramjet activation. And then we had to do a lot of experimentation to understand why this went wrong and analysis. And based on that, we went to the School of Artillery in Devlali to fire this at lower zones, firstly, to understand if everything is fired. So this was successful, and after this, we recently went to Occurrence and tested again. Zone 4, that is something similar to what we can test in Bofo's gun. So as you can see, the ramjet is activated and it is functioning. But unfortunately, the experiment is not complete. As I said, things don't go your way. You do all things on your side, but the radar didn't pick up where the round landed. So you will have to go back again and do it so that the radars can pick it up and we can establish the ring.
Talk about what we have been doing in our group for the last, let's say, 14-15 years, and so some of the glimpses of the work, because time is short and going into each of the problems will take a lot of time. So before I begin with, I'd just like to acknowledge the group who have been involved with this activity. Obviously, all the group members, past, present, and who have been contributing to the work, the funding agencies, and obviously the computing facilities that we have in Kanpur, and some of the facilities that we have used across the country as well. So, just to give you an idea, I did my journey. Started my journey in 1998, then moved to IIT Kanpur, PhD in 2009, then some time for postdoc in Delhi, and then G for a year or so, and moved back to Kanpur in 2011. Since then I have been there, and then meanwhile a year and a half I was in Germany as well. And these are some of the collaborators where we have been working closely for their something. Most of the time their database that we use. Quickly look at that. This is what I just said, that I've been into the system since 2011 and from the academic environment. And these are some of my research areas that I have been working on. Now this is the outline of today's talk. So I'll just give you quickly what is the motivation when you talk about this scale or multi-scale simulations, and then what is the approach, and give you some of the few examples, not picking too many examples here because there could be a lot and there is no end to it, because today's day is where we stand actually take this simulation paradigm to the next level of application of game changer, and some results I will show you. So why do we need multi-scale? Obviously, most of our engineering problems, or rather majority, not the 90% of the engineering problems, are having multiple scale, which are happening dynamically at the same time. For example, if you look at a simple example where the supersonic flow is going over a simple state, obviously it's a wall-bounded flow, you can see a lot of scales which are taking place, small scale, large scale. So one needs to have one single unified framework which would be able to capture that thing here. Obviously, that's where your single scale limit comes into the picture, because once you try to capture those kind of dynamic feature in one single scale, and then rather having an approximation or kind of leaving out some of the other scales into the flow, then you will have inaccuracies in the result. Simply, if you look at these jet acoustics, where there are the small scale, then you have this large scale structure, and there is a feedback loop mechanisms coupled together that creates that wave propagation. Obviously, the way simply I'm defining the acoustic propagation may not be that simple, but just to give you an idea how things happen. Obviously, the bridging scale makes a lot of advantageous situation for you, that you can bring the multi-physics and multi-scale accuracy. And this is another example where you can see that I have two-phase system where you have these liquid jets coming out. They are having ligaments, then it breaks down to the small droplets when it goes to the Lagrangian framework. That means in one single go, I need to have something which will have both Eulerian and Lagrangian, and along with all your surface curvatures, and that what we are able to do today because of the HPC era that we have. We are actually dealing with really Zexa system at this moment. So that kind of system allows us to take care of this kind of things. So as I said that we need a unified framework which would be able to capture all the scales in one go. And this is another example where you have the wall that we will try to do, some RAM switcher who are familiar with the turbulence models and all these, that's something actually models a complete spectrum, and the other large scale. So I have one unique framework which would capture both the things, because why I'm talking about that unifying framework, at the same time I have to get my problem solved so quickly, because engineering problems are actually time consuming large scale problems. Then multi-physics, that's another issue, because those problems are not at all segregated. Earlier 70s, 80s or early 90s used to segregate the problem. That means you do one segment, then you take that data to, even probably today aeroelasticity problem is solved with that way in the industrial scale. But we can have a framework, so you bring in everything together. Obviously, why we are talking about so confidently that we can do that, because of the computing platform that we have, probably 20 years back. And then you need to come up with a lot of different new algorithms. Some of them, like as I said, the unified RANS models, or while doing the simulations, you do mesh refinement, or complex geometries can be represented like this kind of immersed bodies, which is avoiding body-fitted grids and all these things. So that would allow you to have a framework which allows you to get solved problem quickly, and also you will have a lot of predictive capabilities with the multi-physics involved in it. So as I said, the methodologies that we have been adopting, one of them is the hybrid RANS LES. So this work we have adopted for some of this ADU work earlier, that we are looking at the shape modifications as the airfoil, and how you can changes their stall limit, essentially pushing the stall limit further. Then we had a DNS calculations where we are looking at, here you can see the small to large scale, and because these are few million points calculation takes few months, but today we can talk about those things because of the computer we have. Then the again image boundary work which we took up, again it can does a lot of complex problem with ease actually. And data-driven tool were also applied to some of the renewable energy systems where we are predicting or focusing the wind turbine data, and some of the energy harvesting data that we have a lot of simulation data to train our model and do that. For coming back to the applications where, again, as I said that I'm picking up some only few examples. Let's see, if you talk about aerospace engineering, where you talk about when the fighters actually drop the bombs and all this, that's the weapon where there a lot of cavity system happens. So you have, due to the fluid dynamics, you have a lot of noise. And this noise can create trouble. So one of the issues is that how to mitigate that noise. So there are different strategies people adopt. So some of the strategies, like you can have a front cavity or back cavity, so that you reduce those dynamical features that essentially you reduce the noise and the stable system you achieve. Then combustion instability. This is another example which you have done for the ISRO, where they have a multi-7 element combustor, which is basically for their methane LOX combustion, where we are trying to look at their injector dynamics coupled with the system. So obviously, when you try to have, this is only just a couple of examples to give you a glimpse that what kind of applications in aerospace, there can be enormous other applications to that. If we come to the energy system, obviously we talk about gas turbines, other turbines where we have low emissions system, you reduce NOx and temperatures and all these things, so this can have a clean and efficient system. Turbo-based flows, where you have secondary flow predictions, flow leakage, blade aerodynamics, all these could be, or fluid structure interactions in the renewable systems like wind turbine, hydro turbines, and all these things, or maybe the heat exchanger. And another interesting application which I just picked it up because some of the works also we have been doing out of curiosity. Like you look at this kind of blood flows at large arteries so that you can have some predictive capabilities. Because this is where I think yesterday's one of the inaugural talk was on that where we are heading the biomedical systems or this kind of another system which is in the brain, and this shows some of the calculations that we did some point of time, which is the artery is not in healthy condition. Obviously, the futuristic medicine that should be in that order. There, not the specific treatment where it can work, may not work. Rather, you have a data that the system is trained so that it would be. So this is where probably the biomedical engineering is heading, where our database or data-driven system can become quite handy. Now coming back to some of our work that we have been doing, this is on the high-speed area that we have done a lot of coupled this multi-scale solvers. Some for the ISRO, some of for the DRDL for their hypersonic system. So this is what for the work that we did for ISRO, where we did a coupled aeroacoustic simulation. This is a 1.4 jet with a plate and how the acoustics propagation happens. So this we captured. Then this is an intake, hypersonic intakes, where we are trying to look at the sub-boundary layer interactions and why the unstart happens. Obviously, while looking at that, so here also we did deliver the DRDL, some of the codes which can be used for the design. And this work is also for the DRDL there, where we are trying to mitigate the cavity oscillations as I talked about earlier. So this work have already been published, some of the area work, so this, then coming back to the area where we have again a multi-scale solver that looking at the combustion, this to show you the two-phase atomization problem, but both oil and light engine, then we take it to the actually liquid phase combustion, which is your all automobile system or gas turbine system, or you talk about the rocket combustor, the one which is showing that the dynamics between the injector mass dynamics and the combustion instability where it triggers. Then this is again immerse boundary technique, where we are looking at these flapping systems, where you look at the biomedical, mimicking the insect flights or something like that, or you look at the three-dimensional aspect things, or sub-boundary interactions to capture where both the sides where the shock moves the bodies and all this. And then some of the applications we have been doing in the coupled system, wind turbine or the control of the hydro turbines, or this is where mitigation of the hydrokinetic turbine, that where we can improve the power output, or some of the other things where from the year of the, this is for the chip design, where we are trying to look at the thermal managements or the enhancement due to very narrow path. So where we are going ahead in the future look, the digital twin, probably when you have a system, real life system that can predict what can happen, and this is where your high fidelity data or the exascale computing. This is again some data that we are working on, and it can show you the number. So that's what I said, the exascale data where we can actually do a full scale simulation, or we can do some really applying to the transport energy and something like that. For example, you talk about EV, what would be the aerodynamics, how to optimize the aerodynamics of the EV or the fuel. So what it requires is that collaborations, industry, academia, and obviously a lot of interdisciplinary systems, they need to come on board. As I said, the bridging scale that provides you the better solution, and obviously it has already a proven impact in different areas. Some of the areas I have just shown you. So you can come up with some more modelings and all this, and with the advent of the HPI AI system, probably it can actually allow you to get full scale simulation of it in a year after day. Thank you, and I would like to pick up some
Questions, please. Sir, up to how many marks we can simulate it?
which one?
Mark, sound waves.
Sound waves, right now we have done up to Mach 2.2 jet, but you can go higher than that.
So, based on Mach level, reliability will also get changed.
Yeah, that's there, because we have done it, even low Mark 2, Mark 2.2, we have done it. So beyond that also, the framework is capable of doing that, but we have not done any problem beyond that, because even the typical hotted J that would come around Mark 2, 2.2, that was done.
Because the mark variation, definitely acoustic character also will get changed.
Yes.
So how it will correlate?
See, you look at the framework is capable of doing that. It's nothing to do with it to change the mark. Since we have not touched because the requirement was different, but it can do that. It doesn't change your paradigm of the framework that you have. You have to solve the compressible flow, and you have an acoustic system which is solving the acoustic part of the system. It's just coupled together. So it doesn't require what is your limitation. There is no as such limitation in that sense.
I'm happy about the work, what has come in my life actually. After finishing my PhD at IIT in 1995, that is control system, full of theory, full of mathematics. Actually, I came here and I was recruited by Dr. Kalam. He had formed a team called National Control Team, and they had selected scientists from various labs. Dr. Vidyasagar came to IIT, and I came reluctantly because I wanted to be in academics, truly speaking, actually. But I thought I'll stay 1 year, and maybe with Vidyasagar I'll work and it will be postdoc expense, and I didn't want to go abroad in fact. And then I came here, but then I realized I think till SCA first flight, I should stay here. And Tejas is a name that are not given. But when first flight happened, it was a baby step. Actually. Really, it was a baby step actually. It was a small thing. It was a technology demonstration. We used to call technology demonstration. Then obviously, by the time the seeds of patriotism, all those things, my grandfather was a freedom fighter. It was already deeply sold. But my wish was to go to the squadron actually. And should go to the squadron, not just because it is indigenous, but it should be a state-of-the-art aircraft. It's like to our pilot, I cannot say just because it is indigenous sold, you fight against the gun. That's not fair actually. You have to make sure that when we are giving aircraft, and if neighboring country has got F-16, we must have better than that. And that was it. So from technology demonstration, making a flying aircraft, covering the full flight envelope, then making weaponization, making a full-fledged fighting aircraft, and making a aircraft which will serve at the border, at the same time scaling up for the production. So it is all that steps actually. Technology demonstration to making a product which will be a state-of-the-art product, and keep adding the features so that it remains the link actually. And that was a major challenge. A lot of criticism was there when first that happened. I will not go into that one. And luckily, two talks. One was the flow, other was the previous talk on the missile. I think similar thing is there. Only thing is that we have man on the board. So in the whole universe, if you see, there is no life actually other than on Earth actually. Okay, and it's very precious actually. But he is the best element. Today, if you are in an area where you talk about AI, machine learning, anything you talk about actually. While it's in human brain, we have to brain which has very life is a very different thing. So that fellow has got a much more bigger decision capability, which we are aiding him to do the correctly identified target or anything else. Okay, coming back. This is Tejas aircraft. You can see the delta wing formation flying. One weapon is getting dropped, and few things actually. Just quickly, regards to the fully loaded water machine. There is a fuel carrying in the wing. There are the drop tank where you can extend the range. At you can see the bombs at outboard. There is a CCM missile, we call close combat missile. That is the pilot can see the other aircraft and fire it actually. There is another something called laser guided bomb. One is like a bomb, you drop it, basically you drop it a bomb, it goes on a ballistic trajectory. Otherwise you drop it up, but you can identify and hit the precise target actually. So air to ground, CCM at outboard. Then there is a BVR missile also, beyond visual range. You need radar seeker, other thing, previous talk already covered. But then it is more than like 75 km, 100 km. You can still recognize the target and you can hit it actually. So it has got all kind of potentials actually. And then obviously we know it, we have one side, one country, other side is the Himalayan terrain, and which is the highest altitude aircraft in the world. The highest altitude aircraft in the world. As you go up and up, density decreases, there are all the aerodynamic phenomena happens. But when you are making an aircraft for your country, obviously you have to make sure it satisfies all the requirements. So all these pictures are there, flying in the Himalayan terrain. and hot weather trials. You know it summer, like you are in Bangalore, you will not realize it, but just as you go it. So we had to go to various places, then cockpit design and making sure it's a not only flying platform, it is a fighting platform actually. So that's where it goes on. We have one called Never version actually, which has not run to the squadron, but as a technology demonstration, we have already made sure it is able to take off from the short runway and it is able to take off from the carrier. We have done more than 100 landings. It's a single seater. Our Navy technology demonstration phase is over. Our Navy wants a twin engine take fighter, twin engine basically. So my submission to always Navy is buy this aircraft as a training platform. Okay, and okay. So my top mindset, I'll make sure that I go fast. At the same time, my previous speakers have covered a lot actually. So typically, AC is like lightweight single engine, multi-roles, air to ground, air to air, actually. Supersonic, goes more than the speed of sound, actually. And all other day and night company. It is tailless compound. Typically in civil aircraft, you will see the wings and the tail is there. In this case, we use a delta airframe. So same elevator surfaces, which are used for the elevator. Basically, aircraft has got pitch, roll, and yaw motion. So basically, the surfaces at the tail generally they are used for the pitching motion. But when you on the aileron, one surface goes down, other one it's called aileron. So that is what is there in the civilian typical wing and tail configuration. We have this tailless delta curve, but this is mainly for supersonic. Like it is made so that you get in supersonic maneuverability. And you imagine when you have an aircraft which is flying subsonic and you drop a bomb, it will cover some range. BUR missile, if you are already supersonic and if you send a BUR missile, you can cover a much bigger range actually, because it has got already that velocity, and that's where it speaks of actually. Relaxed longitudinal stability. So it is this is made intentionally aerodynamically unstable, so that when pilot pulls it, basically aircraft goes quickly there. Actually, so that agility part comes very very fast actually. And you would have seen all air show manuals, usually they just carrying out, and then it really speaks up to the world actually. That's what it is. So relaxed longitudinal stability, and this is the key element where this aircraft cannot be flown without the flight control system actually. And because it is so unstable, so because of that, this quarter-based flight control system is required. And this is the place where I played the bigger role. 30 years I have been in this program. Actually, as I said, okay, I just give this part what aircraft can do actually. There are many other things I have covered. Only here one part I will say that any aircraft at certain angle of attack, actually it will stall it or it will depart it actually. So this is the curve which is the angle of attack versus the lift coefficient. At this point, it is going to stall it. Objective is that aircraft is unstable. Controller is going to stabilize. But pilot job is not to fly. Pilot job is to make sure that he should fight it. He should be commanding the aircraft. So when he pulls back the stick, aircraft will go it actually, but without departing. It will make sure he is able to fly at the edge of the flight aircraft. So one is aircraft is getting stabilized. Other is making sure that he is not departing. Actually, so we call it carefree maneuvering. Means he is able to maneuver everything, but without worrying about aircraft departing. He is commanding. He is no more flying aircraft. He is just commanding. And that is the aircraft which you are making. So this is one aspect actually, and obviously, I'll just keep this part actually. So aircraft is, I already talked about the conventional aircraft like this stable. Our LC is unstable, therefore the rigid flight control system. I'm going to skip it this part, but the advantage is because it is made unstable, you get gain in the lift, and because of the decrease in the drag. But that is not the main purpose. Main purpose is maneuverability. You can carry more weapons, more passengers, anything actually. This part is supersonic. As my voice is reaching to your ear, obviously you are getting compressed. But then as you start going, the shock wave forms it actually, the cone shock wave. So what happens? The lift, the center of lift starts moving backward. In conventional aircraft, say think of MiG-21 or like that, which is mechanically stabilized. So it has lift start moving back, it has to go supersonic. So it becomes almost impossible to maneuver. This it is a stable aircraft. It becomes like a car. Think of car versus bike. Bike has got more maneuverability. So this is what it happens actually. So by making intentionally unstable, in our case also lift moves it, but it becomes neutral stable or just stable. but the supersonic maneuverability picked up. Now you see the supersonic, I am able to give the PUR missile, getting higher range, it has got maneuverability. So that is where it becomes a state of the art basically. Actually. So obviously digital flight control system is a must actually. But if you have got one computer, it can stabilize. But if fails, nothing. You will have to reject it. So therefore quadruplex is made. What is it? Quadruplex, all four are working together. First failure, still operation. Second failure, yeah. I'll make sure. Thank you. The second failure operator. So fails it, what do you take? Okay, I am going to skip it. I think I have conveyed it. Okay. This is a flight error, typical. This is a bookish flight error actually. So we have got something called a speed versus load envelope. So as you are like one is like a flying at a low speed, but as you go to higher speed, the lift generated lift is equal to weight is 1g. As you go to higher g, you can go to 8g and 9g like that. You can go to use, you can load break the structural airframe also if you deflect the control. So you have to make sure it's not a AOA which is going to control, but you have to make sure that even the normal acceleration you have to control. And then while doing this one, pilot G should get inflated. He starts using the whatsoever that calf muscles and everything, so that he's still like a G lock doesn't happen for it. So these are the all other things complete. Previous talk already it was covered about system engineering and multidisciplinary, and that is the kind of thing. So in this was key part comes the handling. One is a stabilizing aircraft, but giving a good handling quality. That's the very key part actually. And we have got a spectrum of the pilot and human being. It is very difficult to model the transformation. It's a qualitative part. Handling quality is a qualitative part. We have to map into quantitative actually. And then how do we do it actually? So various simulators we use it actually. And then various criteria there. Couple of papers are published and all other stories are there here actually. But overall, it is going into the designing, going to the hardware, going into the system. And all over the nation, we have got a various things actually, especially in Bangalore, we have got across the HR runway, across that we have got various hangars, and then ARDC has got a reach where we did the controller testing. Previous talk already covered multidisciplinary, whether it is a missile problem or aircraft problem or the rocket problem, launch vehicle, all have got multidisciplinary. It's not only aero actually, but control guidance plays a very key role actually. Then when you fly the first time, obviously you need to do aero calibration, aero update, flight envelope expansion. You are done based on wind terrain design. Make sure so it itself is a lengthy process, and because of the man on the board, yeah, you have to be very cautious. It's not only the control system; it's the identification. It is a making sure that you are going to fly at a edge of the flight envelope. So you see in order to give a product to the squadron, you have to fly carefree maneuvering. You have to do that. You need to certify carefree maneuvering. You need to do careless flying, and that's the key part. Make sure that while doing this one, you still have a feature that like you go gradually, and that's fixed off actually. Okay, and then comes in the hands-off flying, that is autopilot. So design cycle is okay. Starts from internet data and other things. Okay, I'm going to end here. Okay. Yes. Okay. Yeah. So like and then after that, trying it goes into the entire loop, and then finally in the end, after testing all these things, goes to production control. So that is where it stops actually. So I stop here, and my journey was more from a mathematician to a practical engineer.
Today I am going to talk about climate resilient geotechnical infrastructure for a sustainable future. The outline of my presentation is I will be briefly discussing about the research focus, then the contributions which we have made so far in this field, and then concluding remark. We all know that climate change is evident and is a modern day trend. Therefore, we are receiving increased intensity of rainfall. We have issues related to groundwater abstraction as well as drought. And this is impacting various geotechnical infrastructure. Our aim of research is to recognize this interaction between climate and geoinfrastructure, such as subgrade soil, slopes, and foundation. Our approach is more than reactive approach than preventive. We understand we are dealing here with a natural material that has tendency to respond to changing water condition. And because of that, the property of this material, which is soil, changes under the condition when it is subjected to drying, wetting phenomena. We aim to achieve this understanding through laboratory testing, field monitoring, and numerical modeling. There are several challenges when we look into the field related to geoinfrastructure. As you see that when the train is crossing, and here we have the ballast which is fouled, the ballast is subjected, the subgrade soil, it is subjected to deformation when the train is moving. Similarly, because of heavy rainfall, there was a derailment of Kamaini Express, and there were so many problems that has happened in recent years to the performance of various Indian infrastructure. As you can see that because of heavy rainfall, there was a collapse of this particular building where the pile foundation is exposed, and coming from Himachal, we received lot of landslides, and the frequency of landslides have increased in recent years. We have seen this year as well as in 2023, and these years were never before when we compare the intensity and frequency of landslides which has increased. So we should realize that the impact of extreme weather event and climate change is accelerating faster than its planning. Therefore, we must incorporate the hydraulic loading while designing geotechnical infrastructure. The way to include it would be through suction, which is the negative pore water pressure present within the soil particle at its contact when the soil is present in an unsaturated state, which is mainly the difference between air pressure and water pressure when water pressure is lower than air pressure. And it is represented in terms of soil water retention characteristic, as you can see over here, which is the relationship between degree of saturation that indicates the amount of water which is present within the voids of the soil to soil suction, and the property of it is highly variable. That means it is depending on how soil is subjected to wetting and drying. Because this particular property of soil, which is suction, affects the strength of the material, its water holding capacity, its volumetric behavior, as well as stiffness, and therefore the infrastructure performance gets affected when the soils are present in an unsaturated state and it is subjected to wetting and drying phenomena. The way to measure it would be through this device which is called tensiometer. This is the device rig that we have developed in our laboratory, aiming to understand the volume change characteristic of the material and measure suction, then represent it onto this space to understand its engineering behavior. In order to first understand that how material behaves under wetting and drying phenomena, combined with the loading that comes because of traffic, let us say for the linear infrastructure, it can be mechanical loading and in terms of monotonic and cyclic. We devised the testing protocol where we kept tensiometer onto the sample, then we subjected the soil to different cycles of wetting and drying, and then we applied cyclic loading to understand the performance of subgrade soil. We subjected the sample to different levels of hydraulic loading. First was free to drain loading, that means the samples were fully saturated, voids were completely filled up with water, and then we applied mechanical loading. We applied another case where we subjected the soil to a constant water content, applied mechanical loading, and then we simulated another condition where we injected the water, applied the mechanical loading, simulated the condition when the rainfall is happening at the same time train is moving onto the pavement. So with the help of this, we were able to understand that the suction characteristic, which is governing characteristic of material strength, is not able to fully capture the material behavior, we need to consider the stages of hydraulic loading. We need to consider that how wetting and drying path is applied. As you can see from here, when the sample is subjected to different drying and wetting path, the samples behave differently. This is the result of cyclic loading. When we apply mechanical loading, which is in terms of monotonic loading, we observe that the sample, when it is subjected to higher hydraulic path, that means the soil developed crack, and that eventually came up in terms of evolution of its denatonic stress. So it affects the behavior. So we need to account for both of these conditions, and we understood that the cycles of hydraulic loading affect the behavior of material, either it is when it is subjected to monotonic loading or cyclic loading in terms of mechanical loading. Therefore, in order to understand that how we can limit the water infiltration within the material, therefore we developed a technological solution. We chose a waste which comes from water treatment plant, and that is water treatment residue, which is having very high amount of fines. It is high plasticity silt. Being a very high plasticity silt and high amount of fines, it has higher surface area, so it can absorb water onto its surface. So we mix it with the soil, place it onto the top, and then we allowed the system to go for different cycles of wetting and drying. Aim was that when the water is coming into, it can absorb the water into its surface, and eventually it can release it back to the atmosphere when the drying phenomena is. We conducted this test for more than 3 years, so this test is still ongoing, and then we were able to develop this, that we can control the infiltration within the soil. And when we can control the infiltration, we can preserve the compacted state of the material. Either it can be useful for landslides phenomena, or it can be useful for pavements such as railways and roadways. Coming to another topic of our contribution. So through this, on combined pile raft foundation, I was introduced to this topic during my master at IIT Bombay. So this particular foundation is usually used for high-rise buildings, where the capacity of both pile and raft are utilized together, and thank you, sir. And because of that, it can serve as a cost-saving foundation alternative. This foundation was successfully used in Messenger Tower in Germany, where $5.9 billion were saved because of utilization of this foundation concept. Earlier, there was no prediction model to obtain the capacity of this foundation system, where we can obtain the capacity of this foundation system by obtaining the capacity of single pile. We have IS code IS 2911 for that, IS 6403 to obtain the capacity of raft. Through our research, we obtained the capacity of, we predicted, or we given the equation to obtain the capacity of combined pile raft foundation system by proposing the equation to obtain various interaction factor that governs the load bearing mechanism of this hybrid system. We utilize this concept for several buildings. Out of this, I am highlighting this one particular building of raw material fertilizer plant of Vietnam. And in addition to that, after so many years of working into this, I was fortunate enough to co-author the code of practice, the India's first code of practice on design and construction of combined pile raft foundation, which is IS 19117, recently published by Bureau of Indian Standard. Then we try to understand that when this foundation is subjected to wetting and drying, how this foundation responds to that. And therefore, we subjected the pile foundation to different conditions of wetting and drying. One can be groundwater abstraction, another can be rainfall infiltration. We found out that the groundwater abstraction or the groundwater addition helps in building so much of additional load to the pile foundation, and that needs to be accounted. We considered the case of freestanding pile, where when ground is moving up, it has tendency to move the pile up from the top, and then it has tendency to pull the pile down, and that creates lots of tension to the pile that we obtain through this. And we highlighted that this loading consideration, which is not considered till now into the design, must be considered for lightly loaded structure. We also have developed this physical model at IIT Mandi, trying to understand the water migration, and when the water migration is happening, how wetting and drying phenomena would affect the performance of pipe. We have currently 1 year of monitoring. We are trying to understand the load bearing mechanism of pipe, which eventually can contribute to the practice in terms of design of pile foundation, which is yet to be established. Coming to my concluding remark, through our research, we were able to establish experimental framework for subgrid soil, including water path, hydraulic hysteresis, as well as mechanical loading. We developed a technological solution to limit water infiltration. We provided settlement-based capacity for combined pile rock foundation, as well as we accounted that how changes into soil suction and volume can cause uplift to the pile or tensile forces it can generate to the pile, which was contrary to earlier findings. And also we co-authored India's first code of practice on combined pile rock foundation system. With this, I would like to acknowledge my PhD supervisor, Professor Sivakumar, my postdoc supervisor, Professor David Toll from Durham University, my students and funding body and various collaborating institutions. Thank you very much.
Good afternoon, sir. I am Arun Kiran from Nuclear Fuel Complex, Hyderabad. And thank you IIT for selecting me as an associate and giving me the opportunity to present our work here. So as a brief introduction, Nuclear Fuel Complex is the only complex in India under one roof which manufactures fuel as well as structural materials for nuclear power reactors. So since nuclear fuel, it should follow stringent quality standards for its integrity in the operation. And the NFC mandate of nuclear fuel complex is manufacturing fuels as well as structural materials, core materials, special materials for defense, space, and other strategic applications. So with this brief introduction, we will go to the genesis of our division. I am working at Equipment Development Automation Division, so which works on developing special purpose machines, automation systems, and technologies for niche requirements of nuclear fuel fabrication. So since nuclear fuel, it should have stringent quality standards, because any deviation in its performance in the reactor will lead to release of radioactivity in the reactor. So for that, we are having some specialized operations which need special purpose machines because the requirements are niche, and we have to manufacture new fuel designs. So new fuel designs are developed by BRC and HGCAR, and to meet their requirements, we have to manufacture new designs. So all the special purpose machines should have automation integrated, so as to remove or shorten the involvement of manpower technicians or the operation of the machine, which will have direct impact on the quality. So we have taken up in-house design of critical equipments, some special engineering applications. So such applications I will be representing outlining in this presentation. The first one is in situ guide diameter reduction of radioactive PFBR subassembly. So PFBR being the second stage reactor in nuclear power program of India, and it operates with fast neutrons. And the first PFBR is under commissioning right now at Karmakar. So these are typical fuel subassembly of PFBR. It is 4.5 meter long and weighing around 320 kg. The fuel will be in this part. So the design is such that the entire long subassembly, it is supported inside grip plate of the reactor at this discriminator location. So the subassembly is supported laterally at this discriminator, axially it is supported at this location. And this stays in the reactor for about 6 months, and after its radiation, that will be subassembly will be removed from the reactor. So during the mock-up price, all the fuel assemblies are manufactured and they are delivered to the reactor site. So during the mock-up trials of loading and unloading tools, these fuel sub-assemblies got stuck in the reactor heat sleeve. So in the root cause analysis, it was found out that some radial clearance has to be increased between this discriminator guide diameter and its melting path. So a 50 to 100 microns increase in the clearance is given by designers. So because this is the setup condition, when there is an interaction between discriminator and the grid sleeve, the excess material got discharged into the cap. So the force to extract was very huge. So there is a brief RCA report from the designers of reactor. So the requirement is to guide this diameter reduction by 20 to 100 microns radially, and all the assemblies are manufactured. They are filled with plutonium oxide fuel. So zero rejection has to be respected. Any rejection due to overgrinding this part will lead to rejection of the entire fuel cell assembly. And as you know, plutonium oxide is not naturally available reactive isotope. It is a man-made. And we have to maintain concentricity of this axis after removal with respect to this foot axis, and it should be within 50 microns. So the challenge is there is no ready-made solution for it. We have to engineer the solution. Then the operation should be remote because it's a reactive sub-assembly, and we have to meet this schedule. And it is very long sub-assembly with good weight. And the discriminator or the section in which we have to make, it is not a complete circular section. It is having 3 segmental cuts. So this design is because to have some leakage sodium cooling flow in the reactor. There are no hydraulic studies. This shape has come. So the design is, we have designed a CNC belt grinder machine where we can speed, feed, drag angle, everything we can control with CNC. And that grinder self-centers with this sub-assembly. And we gave automatic sub-assembly arrangement also. And it is having many programmable parameters for target material removal. Because in manufacturing we have this tolerance. So the tolerance band of this one, depending on the as-built tolerance, so we have to material removal should be variable to get the required panel dimension. Then we have to qualify the process, because without proper qualification we don't get approval to touch the radioactive product. So here what we have done, these are mock-up test pieces which we have made. So this the entire section we have divided into 16 cells, wherein we have made a 0.1 mm deep groove, and we have measured the material removal by measuring the step height before and after grinding, so that we need to have a uniform material removal of 15 microns across and along the length. Subsequent to qualification, we have executed, we have installed the machine at the reactor site, and we have qualified at the reactor site, and all the 370 sub-assemblies are modified with 100% recovery. So on-time execution, this facilitated loading the blanket, and last year March, Honorable Prime Minister visited the reactor site also. So we got our clearance from a regulator for the concept, design, qualification, operation time and operated dose, because putting the sub-assembly onto the machine, dialing it, setting the parameters is manual, because the dimensions vary from sub-assembly to sub-assembly. So only this part is manual, the remaining grinding part is automatic. So even this for small this process also, we have calculated the time, and the dose is estimated by the reactor physicist, and it is proved that the dosage limits are very less, beyond the actual limit. So the novelty is there is a self-centering and grind force control. We are having a numerical control of position, speed and wrap, and we have used standard belts available in the market for different grid sizes, and we are having overgrind protection. And with this grinds, any geometry or material programmable removal rate. So as such, the tool can be generic. So this is a 3D model of the tool. So this is the plan view. This is the sub-assembly. This is the discriminator part. Here it is having self-centered design. We are using a standard belt. We are doing grinding force here. So we are doing rotation to the sub-assembly as well as linear speed to the belt. So this can be programmable and vary. So we have optimized the parameters for this material. As such, this tool can be used and engineered to do different geometries also. The next application is profile welding machine for strategic applications, because everything now the entire country is moving towards net zero to decarbonize. So in that machine, mission, nuclear power is a sustainable option. So for that, different capacities, reactors with novel and innovative designs, different capacities for strategic applications as well as for civil applications are being designed. So for one such typical application, there is a requirement of welding thin wall components along intricate profiles, because different sub-assembly designs will have different profiles, different materials, different design requirements. So this one machine which we have made, and the challenge in this machine is we have to do automatic welding, and the machine should be able, we can able to easily the required bead, depth of penetration, and the measurement between the components should be ensured in this. Different sizes and different geometries. So the design is 7-axis auto touch machine. We have rotation, XY interpolation, 2-axis weaving, that having programmable weld cycles. The novel part of this design is we can generate the program. For example, to get required shape like ellipse, square or anything, there should be a synchronization between C-axis and Z-axis of the touch. So both these modes can be synced by using a teach-based approach. So in the space, we teach some points, the profile on different points on the profile. Then the system automatically interpolates using some functions and calculates the rotation versus linear velocity of the touch. And with that program, we can get the required shape. So this is a picture of that 7-axis machine, C-axis, Z-axis. Then we are having XY interpolation of touch. Then we are having delta X, delta Y to get the required weaving to get the sound convex profile shape. Then we have qualified this process for square, hexagon, and ellipse profiles. So the overall is a teach profile. So wherein any profile can be taught in 3D, and it's a modular design. Like the entire things are in modules. Suppose if you wanted to weld a big channel, a big pipe along its length, we can reorient the head in such a way, and we can do the welding also. And this one is compatible for TIG, EB, and laser with and without filler also. We are used TIG in this process because of the design requirement, but the same thing can be used with laser also. The next application is radioactive granular transfer system. So in PSW, pressurized heavy water reactor, uranium dioxide pellets are pressed, cold pressed to get the required shape and densification. So in that process, previously NFC is having hydraulic based final compaction presses. So NFC has gone to rotary press technology. In that press, the production is fourfold, from 30 kg per hour to 120 kg per hour. But the challenge in this was the supplier of the press did not, the granules has to be loaded. So the hopper of the press is an elevation of 4 meters from the ground. So 120 kg granules, they have to be taken, they have to be lifted to 4 meters and they have to be filled into the press. Because the plant was very old, so there is no much space in the plant to put a first floor or second floor gravity based loading system. So we have to lift it from the ground. So for that we have made a quick system so that we need to meet the commission schedule of the press. This was imported press. So it's a 4 meter transit system. So the entire lift is around 5 meters. Then there will be swelling, there will be tilting, and there will be gravity. Then once after such high elevation of 4 meters, if there is any leakage in the radioactive granules, so that will lead to the airborne activity in the shop floor. So for that we have designed an innovative conical valve assembly, a spring-based system. So here we have locating, docking, sealing, and opening, so that there is leak-proof system of granules from hopper to the hopper of the press. The next part is small automation which we have done, green pellet density measurement system. So the pellets which are pressed the previous the rotary press, they are called green pellets because they are virgin pressed pellets. So here we need to measure the density of the pellet. The beauty is the diameter length of the pellet are constant because we are we are pressing it at 100 bar pressure. So here since the geometry concentricity as well as the simplicity of the pellet is unique, so we have used a slightly LED micrometer to measure the diameter and length of the pellet. From this we can calculate the mass, we can calculate volume, then we will measure the mass and finally calculate density. Previously the operation was being done manually using micrometers. So with this there is an improvement in the radioactive exposure to the operator also. The next part is appendage welding machine. So this is a typical PSW fuel sub-assembly. So here if you see these are 1930 element sub-assemblies. Small tiny appendages like spacer pads, bearing pads are welded onto the assembly for different functional requirements in the reactor. So towards that, our predecessors have designed a resistance based welding machines, and we are now continuing that technology to manufacture a series of machines for NFC and a new plant that is set up at NFC quota. So if you can see the dimensions very thin, 8.6 by 2.5 mm. We have 3 thickness variations, 0.6, 0.8, 3.25 mm, and varying part is 33 mm by 2.5 mm, thickness of 1.1, 1.9. So very tiny pads. And here we need to weld it so that during welding there is no indentation on the ID of a 0.4 mm tube. The thickness of the tube is very small, it's 0.4 mm. So with no indentation on the ID side, you have to weld it. So the requirement is to go for manufacture series of machines. And the challenge is the machine should have automation for accommodating different sizes and thickness of the tubes. So we have made a machine, and since the resistance welding machine, we are going with the surgical process control. So wherein 300 continuous welds we will do, and we will do the strength testing, distortion testing, and the X bar minus mean sigma should be less than the required limits. Because like that, once you qualify the machine, then all the subsequent production in that shift is qualified. So we have also incorporated some innovative defect mitigation systems, because the loading of the components is manual and the entire monitoring is manual. So we have put some solutions like current monitoring, then appendage monitoring, then orientation of the pad, everything. So that we could able to get we could able to achieve very near to 6 sigma, like 10 defective welds in 16.5 lakh welds. And India is the only country in the world to develop this technology, and India is the only country to use resistance projection welding for joining these appendages. So countries like Canada and other nuclear other countries, they are following Brazil. So these are machine. Just view an overview. This is having around 300 components, more than 20 cylinders, and the entire welding operation takes place in less than 1 minute. Wherein we are having 11 appendages and 3 bearing pads. Total 11 weld joints in less than 1 minute. Because NSC is manufacturing around 1000 tons of fuel. So each bundle is around 25 kg, and you can know how many bundles you are manufacturing. So the next one is advanced testing machine. So this is the same weld joint. Once a weld joint is made, we have to detectorily test it as a process of qualification, process and setup. So here also the requirement is to measure the strength for different configurations. The challenge is to have precise alignment of tool and joint, because here you can see there is only 50 micron, 40 to 50 micron collapse. So the tool should actually go and shear this joint. If the tool shears the pad or if it shears the tube, we get higher strength, which we will again, there is not a correct testing method of the system, of the process. So we have made a small gadget for that, and again precise alignment is achieved here. So that because the qualification of the process depends on the accuracy of this testing. So in summary, critical nuclear applications have been achieved for DIE. All our original concepts developed in-house, high reliability, user-friendly. They are fail-proof and foolproof 100% recovery. High level of sophistication is done, and the defect mitigation solutions are also incorporated into the machine. Almost very close to achieving 6 sigma quality. And thank you.